So for quant, if you haven't used SolidWorks, it'll be.
I use SolidWorks.
Okay.
All designs are done by SolidWorks.
Okay, then that will be a very
2008.
straightforward thing.
Yeah.
I'm gonna say, and I'm not trying to convince you guys to use this. You can keep just using SolidWorks. One advantage I could see this being relatively lightweight, because all the rendering and computation are online. And if you are more like a how to say, if you are a fab person by the end, it also does simulation, so you can create animations to pop out your structure. First of all, I'm not sure if SolidWorks also has this, perhaps also, but I'm just showing what does it has. So you also do a relatively realistic engineering. And another thing that's kind of cool is it also has a lot of finite element simulation in it, and I believe it's a little bit simpler than SolidWorks. So for and also this is actually unique. It has pretty strong CAM feature if you want to do CNC machining, designing two path where to mill, like how you make iPhone cases with metal, this type of thing. This is very unique, and also very simple to do drawing. Like in SolidWorks, you have those perspective front, different view, like say if now we're doing like an exhibition, we need to figure out like a construction shelf for the museum. This is also very easy to do, and you can do it from animation to get blowed up views as well. And also it has a lot of, so for example, I can simply go to simulation example, and there are a lot of hands-on experiments I can just see. And one thing I feel very handy is all these are updated in real time, because all of these are in cloud, and I actually don't have those files in my local drive. These are all online in Autodesk servers. They use Amazon service, and you can also check all the basic training tutorials. And if you have used SolidWorks, you almost do not need to check any tutorial, because it's all similar. So you do like a basic sketch, and then you can create all the extrusion, and you can also do dimensioning. You can click it to set different parameters, etc. And one thing, for example, I use Autodesk computer to do all my projects, but then it just, as I'm creating, all of the files will be uploaded into my account. I just need to log into my account to access all the historical files I worked on while I was at Autodesk in San Francisco. So I do think this is very convenient, and you do have this already integrated into your software, so you can, imagine you two are doing something. You can easily share all the files. So that may be an advantage.
Maybe I can learn how to use Fusion.
And you can already see, like, I printed this thing in my video, right? And so for now, I'll go through one very simple process. So say if we want to make a very basic structure. So these ones, if you remember, Tina, I showed you the little frame. Each one of them shrink a little bit, bend and shrink, and the entire thing shrink. So this is the original design file of it. Kwon, maybe did I show you? Maybe I didn't. Let me grab that little box, okay. So you know what I'm. Yeah, the other day we already started to arrange all the little stuff, so we saw this thing. So this was designed like all square, and but you can see all the red part. It's similar to the bilayer. It's a bilayer on the wall, right? So the red is bending inwards. The right side, the white side is bending inwards, and the red side is bending outwards. And this is like a metamaterial structure.
So they are same height, and then they printed simultaneously almost, or once you're white person.
This one I did separately, but ideally, if we use a very precise two nozzle printer, if we set up everything perfectly, you should be able to print one layer this, one layer that, and then stack on top. That's the goal, right?
So this one, how did you print it? Because you said once you print white thing first, or black first, and then you put some white, and then those little can of enough.
Yeah, it will melt the plastic a little bit and then fuse the, Actually, we want it to touch. Otherwise, if you don't have perfect bond, it won't work, right? Yeah. So, I mean, all these shapes. Maybe we can take this as an. Okay, I don't need to. So I think this could be a practice file for you guys for tuning later on. And for now, we can do a even more simpler thing. So this is, maybe I can show you this. This is the flower. Let's just use this since I have the file.
Yeah.
So this is
one, right?
Right. So when I create this 3D file, I actually have both layers, as you can see. So
yeah, the purple one is the black.
Yeah. So I have, so this entire file I would do a hexagon first. This is the bottom. So these are the individual petals.
Maybe you can start with something a little too specific.
I thought this would be better because too spec will be too simple. It doesn't make too much sense. I'm not giving you a tutorial of how to use this software. I'm only telling you how to basically generate two paths based on this geometry that I already created.
I see.
How to make this geometry, you're gonna have to be able to figure out after just listening 30 minutes tutorial, especially if you know SolidWorks already.
Okay.
Basically, create the 2D outline of hexagon extruded to get this, and then I would offset each side a little bit, try to create a gap in between all the 5 different units. And this is like the bottom layer. This is supposed to be the black substrate, and this one I believe it's 0.2 in height. You can check it out. Also, I haven't used it for a long time. Yeah, so okay, so it's 0.3. So why this matters? So the thickness, later you will see. So in the software, we're gonna use 2 software. This to generate 3D geometry, and another software to read 3D geometry and generate the 2 path. So in the second software, where you can define the height of each layer when you use MakerBot to print, and the machine is not super accurate, but the machine is you can also usually set each layer height to be 0.2 or 0.1, and it's sort of recommended, at least in all my tests, I use 0.2. So you can assume if I set this layer as the height of 0.2, then in the machine, in the other software, it will only generate 2 paths to do 1 layer print. But since now I have 0.3 millimeter, in the other software, it will generate 2 paths to do 2 layer print. That means the hexagon will be printed twice, and it should be 0.4 millimeter instead of 0.3. Again, I'm doing very sloppy work, so I didn't ever actually measured how thick it is. I think now we should. So basically, you can print, 1 layer, set it to be. You can, for example, if I were you, I can build a model that's 0.2 millimeter exactly, and build another that's 0.4 exactly, and then measure what's the error of your 3D model and the actual print out of the 3D printer.
Okay. So G-Blocks are only having a layer information. They don't have a height, right?
No. Yeah.
Okay.
No.
Yeah.
No. Because they're gonna be, because the G-code generation software assume the machine is doing a very accurate job. If we say 0.2, the machine will give us a 0.2, right? So it's critical when you design your geometry, make sure it's the it's either 0.2 or 0.4 or 0.6. 0.3 maybe is actually not a good one. I don't know why I made it 0.3. So this is the bottom layer, and then all the hexagons on top. So why it's important to make it 2-layer print, because after my test I figured 2-layer of the soft material will be perfect for the bending. But I think you can also just to test or verify if my hypotheses are right or wrong. You can compare, right? You can print 1-layer soft, 2-layer soft, 3-layer soft with the same thickness of the hard, and compare all these 3 samples. What's the bending curvature for each? Could be interesting. And then talking about the height on top. So usually I print soft material 2-layer, and then the rigid material I usually print it as 3-layer. So I should have set it to 0.6 millimeter, right? Based on what I just mentioned. So the measurement gave me a 0.8. Okay, so in this case, I actually printed 4 layers of the rigid material and 2 layers of the bottom material. So then that's it. So once you finish your design, so this is kind of, so now I'm gonna export it. It's important you export it to be, so depending on how you want to generate your 2 paths. So if you want to set these 2 paths separately, you're gonna have to export them separately. So in this case, I actually want to generate all of them separately. The reason I will tell you later. So how to do this? This is the bottom substrate. I'm gonna close this. So basically, you choose here and select Save as STL. And you don't need to do anything.
Binary format.
Yeah, binary format, medium refinement. Let's just temporarily put it somewhere. .1. So usually if I've already selected one, I would close it.
So now you're exporting that part, right? Just that pedal.
Yes, and only one pedal. .2. So the goal by the end, hopefully all this can be done. So this is actually something we should discuss. So eventually we should have a more, so we're talking about designing an integrated tool. So perhaps we won't use this interface to select all those things, because we're talking about making our own G-code generator and stuff, right? But for now, for your printing experiments, well, actually, it's not a hexagon. It's only 5 sides. Yes, and this is 6, and it's also the substrate. So okay, that's it. From the Fusion side, and I'm gonna switch to the other software. It's called Simplify 3D, and this one is a paid software, and I have one license, and I believe. I don't know. You guys can decide if you want to install it on the common desktop so everybody can use, or maybe there is a way we can figure out to switch the login and out of the account. There is a single use account, but I believe you can sign up and the other one can sign in. So this is the starting point. Once you install the software, you can select this being a MakerBot. It's called MakerBot Replicator 2x. 2x means there's dual nozzle. So you want to select this one. And next. And finish. And this is so far Autodesk verified most sophisticated G-code generating software. And almost it's like a whole two-path planning for CAM. So you can, for now, from here on, for what we are doing, we are not using dual nozzle printing. If you check some tutorial, it will tell you there is like a dual nozzle wizard that's like some sort of automatically configuring or printing file for dealing with multi-material printing on each layer sort of thing. Although we are using a dual nozzle printer, we're not using this dual extrusion wizard function for a lot of reasons. One being what we are doing is really not standard. If you use those standard software, it just doesn't give you the maximum flexibility. And in the import function, you want to go to the place where you stored your file. So usually I will just, let me think how I do it usually. At this case, I think I can import them all. Ooh. Huh. Okay. This is not working in the way I wished. Because I believe the X, Y, and Z axis and the X, Y, and Z in Fusion is not set in the same way. Yeah, so this one, if you see, the standard is Y-axis up, but here is Z-axis up. And there's, well, at least based on what I know, it's hard to hack this software to change the orientation. So only what we can do is we can reset this. And I forgot where to set this. So I have to see. Oh. But it says Z up, so it should be correct. Maybe because this file is really old. Yeah. So now you get a chance to see we built a much simpler one. So let's do. I'm now basically just making a new file. We can make it. It's pretty much, as you can see, SolidWorks style. We're doing a 3 centimeter by 1 centimeter little rectangle, and you can always press D and redefine the dimension. That's pretty much SolidWorks too. And then I can extrude it and make it. Now I'm defining the height. Let's make it 0.2 millimeter, and you can change millimeter and inch as well. And then that's my substrate. And on top of my substrate, if I want to make another unit that's like the rigid material, I will have to select the surface where I create the second geometry and then do another rectangle. So now I'm printing simply a stripe, and that stripe contains two components, the top layer and the bottom layer. And the top layer, I'll set it to 0.6. That means it will print 3 layers. And here in operation, instead of joint, which will join the two, you want to say new body So because remember we want to create two separate body. So here under body you will see two bodies. So that's bottom and this is the top. And this I will do it again. So right click each individual one, save as STL, right? And so now I want to see this is body one, that's okay. And then this is the bottom one, that's body two. Let's say oh, this is body one, sorry. This is the bottom one. I'll just simply call it bottom. And then I'll call this top. Okay, let's go back to simplify 3D. So for these ones, I can simply remove it. And then I can import new ones, the top and the bottom. So if you put it in like this, automatically it doesn't really align in the way how it was aligned in our CAD model, right? But it does have the two components. So what I do is I will select both and go to center and arrange models. Sorry, align selected model origins. So this now it will come into one. But so you can always zoom in and you can select each individual. But I have to verify because sometimes it will fall all on the platform. But sometimes it has exactly the same arrangement as in the CAD software. So you can easily, for example, now I want to verify. This is the top, and I want to see the. So you can see here the Z offset is 0. I believe it's wait. Let's see. Right. So if I make it even a 0, so I'm just double check. So even I move 0.1, I see it's a gap. So I think it's correct. So basically, you can see here that means this offset means compared to the origin that shows up in this software, what's the offset? So Z stays, Z doesn't change, X and Y changed to 15 and 5, minus 15 and 5. And for the bottom layer, it's the same. So basically, this software moved both items to the center of the printing bed. That's it. But it should be configured right. So now this is exact the mirror of the MakerBot printing platform, right? And we can see it will be printed in the center of the MakerBot. And now once we carefully place it, it's the moment for us to generate the printing tool path, because ultimately we want to generate a printing tool path. That's it. So we want to do it separately. And for the top, and we can maybe name this process double click. We can name this process top. And usually at least what I will say is I will do top even PLA. So I know the top layer is PLA and the bottom layer is the TPU. You can still select this and remember which extruder is PLA, the right extruder, right? So we are making the configuration for the right extruder. However, I believe here we can say configuration for both extruder. Wait, I'm trying to retrieve my memory, and you can select PLA by default. Because it is a pretty common MakerBot material, so there are even some default way to do the print. So you can also select. You have to basically select the advanced function to show all this. There are some basic concepts in terms of all the terminology it used for FDM printing. I think I will send you guys also like some links for basic tutorial. I do suggest you guys to check the basic tutorial of this software and also the basic terminology for FDM printing. So in field percentage, so what we care, we almost have to care all of them. But for now, do the simple one. So the extruder, we want it to be the major extruder to be the right extruder. So we want to see why, because right extruder we loaded the rigid PLA material in it, right? And there are some parameters. These are software recommended nozzle diameter being 0.4. So you can see here it basically means each line will be 0.4 millimeter. At least the software will calculate based on the idea of each line is 0.4 in thickness. And also the multiplier means if you want to extrude more, more than the machine by default calculated, you can also increase this multiplier. Sometimes I do. When we play with the advanced function, for example, if you try to extrude really fast, the machine is getting dragged because it doesn't really catch up with the speed. Maybe you want to increase the multiplier just to hack the machine a little bit. So there are some things like that. And for now, I think you can all leave this as it is. Retraction is very important for PLA. What's retraction function? So basically, once you finish, you finish this part and you want to move to a new location to start your print. And when you finish, because it's viscoelastic material, when it's melted, it will still try to go out. And we want to prevent that to increase the quality of the print. So at this moment, you want to do a little bit of a sucking back. So the retract basically means once I finish 1-2 path, I quickly pull it back a little bit. The motor will drive reversibly. And for this, for PLA, for those rigid material, we usually set it as default because it's a good function. However, for the soft material, we want to uncheck it because you imagine it's very soft. We push it out, we push it in, all the materials will start to wrinkle, and that's very bad. It might get clogged in the extrusion line. So for PLA, remember now we are setting PLA, so we do not need to uncheck it. Leave it as it is. What we really want to do, if you check this, now it goes back to a layer. See, my computer is really slow. It shouldn't be like this. You can see, restart. Yes, so this is important. Primary extruder, we want to set it as right extruder. Again, because we used PLA and we loaded the PLA in our right extruder the other day. And also there's a primary layer height. This is what I meant when we model the file. We said if we wanted to print one layer, we set it 0.2 because the software will consider each layer being 0.2. You can modify this, but this is good enough. So this is also important. It asks you to set how many. So when this software is not designed for us, right? It's designed for printing very tall objects. So in order to make a high quality print, but also fast print, you want to make sure the top and the bottom that are exposed to the end user will be fully filled. That's what it means by solid layer. But then for the middle part, nobody gonna see it, especially the inside of the middle part. So for this part, usually the software will make it loose, print with bigger gaps. That's why this function exists. I'm just trying to say because what we are doing we don't require this software to do this kind of smart calculation to speed up and also make top and bottom higher quality or whatsoever. It's better we turn this off. That means let's make it 0 to make our life easier. 0, 0. That means there's no solid layers and all the layer density will be defined by us later on manually. And then the outline, this is also kind of important. In our case, so the outline means, for example, if I try to print a round shape like this, each layer, it'll have different ways to generate the toolpath, right? It will generate either vertical, horizontal, honeycomb. The outline means, so I will trace the outline, in this case, a round shape, and 2 times. So trace outline 2 times, and then fill in inside with a certain defined pattern. So here we do not want outline. So if you see those examples we printed, we do not have outlines. We simply want those parallel lines to come from the left to the right, all covering. So this outline, we should set it to 0. But it's important for you to know. For now, you can remember as 0, 0, 0, because later on, for some design, we may need outline. So you want to know here is where you set the outline. And for these, I usually also make it 100. 100% layer height. So again, you just need to remember all those functions. So the software set it in the smart way for novice user who know little about 3D printing to get a relatively reasonable high quality print. But for us, because we want fully controllable, so we want to set those parameters to be to be default. So we make it all of them 100. This is also important. Use skirt brim, take it off. There are a lot of information, and all these are not so relevant to our project actually related, but even more relevant to the daily use of the FDM printer. But you kind of want to know what the function is. This is about, so if I want to do a print, usually the printing won't come out perfect. So you want to start printing somewhere else, make sure the filament comes out already smooth before you print your actual object. So this skirt function actually sets, so it will do an offset of the outline of your first layer and start to print a few times before you go to print the real object. And so this offset from parts means the distance of this offset layer from the part. So usually 4 is enough. If you feel like you want to be safe and print a larger skirt, you can also do 6. This I usually turn it on because, as I said, it basically makes sure your printer is running smoothly before you print the important part. So you use skirt and skin. And infill, this is actually kind of important. I will show you what it looks like just as of now. So I make the infill as the right extruder, just as it is. Let's try it. This is the infill angle. OK, I select OK, and then I want to assign this for the, let's say I want to assign this for the top, because top is PLA. So you can select, you can select model here. Select model, and I want to assign it to top. OK. So now I can prepare to print. And you see, so this one generated is the toolpath, and it's the toolpath of only the top part. Because we haven't really assigned anything to the bottom layer.
So your toolpath, you want to making it kind of vertically or horizontally, right?
Right, but I'm just showing you how this can be changed.
Okay. Now then.
Yeah, so this is a simulation. You can see the printing process. So it will start from, so this is reverse, but here it starts from here and gets printed like this. Why? Because let's exit and go to the infill. It says, so basically means this is first layer 45, the other layer, the other side 45. So you can imagine if we change it both to 0, it will print 2 layers, but then these 2 layers will be in parallel, right? So now they are in parallel. And if we want to do another side, so for particularly this print, we are doing this direction. So this should be actually 90. like this. But then you also see the gap is different. So we want to print more tightly. So here we can basically, that's where the infill density is important. So there is an infill percentage. Actually here you can see it as well. And we can drag it to 100%. This is the same parameter. It set it here separately because this is kind of an important one. So you want to highlight, but it basically means here, it's here. And usually you do not need to care so much of these different things. Sometimes I also purposely make it slightly loose. So I may do like 80%. Then sometimes you can even see. So for example, this one, we can clearly see each and every line because it may have only 90% infill. But this one you see is almost formed like an entire film because it's 100% infill. And this does affect the performance a lot because you can easily imagine if we have more lines, of course, it will have bigger force. So here, if I do 100%, you can easily see the difference, right? And this is actually kind of what we want. And you can zoom in and you can see it's being printed 3 layers. But here, however, 3 layers is right. Remember in our CAD software, I set it to be 0.6 in height. And
2 1 layer.
Yeah, I also told you 0.2 is 1 layer. So that's, we're printing the top layer with the rigid material. 0.3, 3 layers. These are the things you have to check every time. And there's a little feature might be interesting to you. There's a movement speed. Remember, I said that's also very important. So this color is actually indicating the moving speed. You can see the green means maybe it's around 3,000 something millimeter per minute. But you can also choose, if you want, you can also choose use active print head to visualize the color. I'll tell you why it's interesting later. But so far, seems good. And the other parameters we need to care, except the more visible geometry, we can also say, sorry, so we are here, so we set infill. We do not need any support, so you don't need to care about this layer at all. And then we go to temperature. That's also important for each and every filament. Kwon has already seen they have specific requirements for melting temperature. And for a PLA, that's the right extruder. That's the only one we need to care, and that's T0. And PLA, usually we set it to about 210. You can print like this for now, and later we can talk about how we can even play with the melting temperature to get different performance. So here we set it to 210. So something you have to notice, this is the right extruder. And for, horrible computer. So let's check OK for now. I'll restart. In temperature, so the left extruder, because for this process, when we are printing the top, we do not want the left extruder to heat up. Otherwise, it's a waste of energy. Also, we try to take turn to heat this one up again, that one again, until this one is heating up. The other one won't be heated up, although the temperature is falling. So that's actually the major reason why I want to print these two materials in 2 separate steps instead of 1 step printing both. Because if I set this 2 material as a procedural in 1 file, the printer will automatically try to heat up both. But because of the power of the machine, it cannot heat up both in the same time. So we try to heat this to 230, and then it switch to another one to heat that up. But as the other one is heating up, the other one is also falling down. But then the machine can't really take care of this one until it finishes heating up that one to the expected temperature. So it affects the printing quality a lot. So then I decided, when we are printing the top layer, we only set the top layer to be to 10, and we ignore this by setting it at 0. And so far, I haven't really figured out what this is for. I believe, or I forgot whether or not we need to change this or not, but we change it anyway. So this machine is also powerful. The building platform can be heated as well. I never heat it. for printing high quality 3D objects, again, you want to heat it up. This parameter actually can affect the transformation a lot. So we want to make sure to set this as 0 as well. And that's okay. So now we can try to confirm it. So that's the temperature layer. You always want to check your settings as well. And cooling, I forgot. I believe we do not need to care. Yeah, fan we don't need to care.
And 3 files. The third one is hit the platform.
Oh,
and
but no.
It's not gonna go that high.
So it's a lot to explain to you guys. But basically, the reason a 3D printer company will design a function called heating bed is to fight against the phenomenon we are trying to use. Because in engineering tools, when you are printing an object, the worst phenomenon you want to see is warping. So warping basically means once you print this plastic, it bends up, right? And you will think this is a loser print. And in order to fight against this warping effect, you heat up the film, the printing bed. Remember, the secret of making things bend that much is because we have a residue stress that's built in by quickly pulling and quickly cooling. But if you have a hot bed, you are actually melting it, make material really compliant as you are printing.
Right.
That will prevent this from happening, which is good for normal printing, but very bad for us.
So my first one is the bottom layer, second one is third layer, and the second layer. The third one is just hit the bed independently, like.
Why you want to hit the bed?
Then we can see everything forms in a one camera shot.
Oh, but the heating the bed is not
high. Okay.
You can make it high, but it's a gradual process. And also, once you print this whole thing is kind of bonded to the bottom. You still need to kind of try to take it off, right?
Oh, I see.
Yeah, even you heat it, it's gonna still stick to the print bed. But it's true that you can use print bed as a hot plate to trigger some transformation later on. Yeah, could be a possibility.
Later,
I know what you're talking about. Yeah.
Just one shot and it's gonna be cool. I mean, I'm thinking about the video but probably need some modification that those kind of heat.
I mean, maybe there can be some smart ways so we can print once we finish printing. I don't know.
Yeah,
we can try. Maybe.
Maybe.
Anyhow, let's go back. So there are some very interesting functions. You may need or may not, but basically you can offset. So say if you figured, oh, we did so much manual putting the paper, calibrate the height and everything, we thought it's perfect, but the print still is too high or too low. Instead of adjusting the hardware, another thing you can do is you can adjust in the software. So for example, if we do a 0.2 millimeter Z offset, it means we are basically kind of lifting up. So we are assuming we are basically printing. We are lifting the nozzle 0.2 millimeter away from the print bed. So in case when you calibrate the hardware it's too low, you can use the software to do an offset. Does it make sense? Later, maybe we'll need a chance to use this trick if we figure some printer not bad. Or if you figure the print is too much on the left hand and you want to make it printed on the right a little bit, then you can also offset X, right? So I actually use this a lot, especially if I figure a certain print is too low or too high. Too low means the print is like scratching the print bed and the printing layer is really thin. Then I would just offset this to be 0.2. The incremental number I usually do 0.2. And you can do some simple modification of the script to modify the beginning, how the temperature is how the printing bed and all the extruder are being heated up. But you can only do certain modification from here. You can set some script for each layer and stuff. But ultimately, I think we should generate this G code outside by ourselves instead of
So G code is already made in G code.
Yeah, yeah. So after
Fine
this,
cake.
after we click around, the G code is already being made in the script, but we won't. So actually, we are able to see the full script. Uh, so since we are here, I can explain a little bit. Maybe this is useful to Quang. So if you see, so for MakerBot, once we choose MakerBot as the default machine, it generates X3G file. But in the same time, it also generates a G code file. So G code file is a standard format for all the 3D gantry system. And we have a lot of other software that we can use to kind of open this G code. And there's also a lot of open source tool to generate G code. But MakerBot takes the X3G file. Ultimately, they are kind of the same deal, but it's just encoded in a different way. And I believe we can also have other open source software to generate X3G. Anyhow, so we're gonna have to figure out a way to write this G code outside of this platform if we want to have full control that's not even being available in this powerful G code generator. And this is also very important. So printing speed, it basically means how fast each line is being printed, right? 4,800 is a mediocre speed. It's a safe speed to get things started. So when I test limit, I sometimes even go like 500 as the slowest, and all the way up to 8,000 as the fastest. Or I have gone to 800, and because I told you guys speed matters in terms of controlling the bending curvature. So this is a parameter later on I imagine we will play with a lot. But for now, for your first test, I suggest you use default, just 5,000, 4,800, that's enough. So for all the other, you make it 100. So all this should be supporting structure, everything. We're not using outline just to be safe. There is also filament diameters. By default, it all should be just correct. There is another thing, I forgot where it is, but we should change it. Maybe it's in the G code.
The 48 is the default.
Yeah.
And the flowers, what's the flower?
The flower.
It is, yeah, some flower or something like maybe for.
This can be achieved by the
48.
Yeah. And another thing, again, advanced function later on. You can also start print at a certain height. Say in your model, you model the entire thing. So you can also model the entire thing as one file. You can also define, for example, print only the first few layers, or or start print from the third layer. So there are reasons why this is important, but later on. That's kind of a general overview of how this software works. So then I've already told you from here you can select model, select the top model, right? And okay, so this one, usually just out of good habit, I will try to make it, I will name it. So for example, this one, we use it to print the top PLA, name it. And then now we want to define the bottom. So maybe we can easily copy one to make our life easier. So I copied another one. This we will make it bottom PLA. Sorry, bottom is what? Bottom is TPU. So by default, there is no TPU. So we don't need to change this. We just have to kind of adjust the parameter. So this one we have to do left extruder. And for this one, make sure in the layer, the major extruder becomes the left extruder. And for this one, that's the soft material. And for the left extruder, all the parameters can be the same. The extrusion multiplier, usually I set it to 1 and even higher than 1, 1.2. Let's start with 1 and you'll see how it goes. And retraction, remember I will unclick it.
What's the multiplier?
Multipliers means basically it's like the extrusion the extrusion speed. So the dispensing rate, yeah.
So PLA is what's the PLA?
PLA is 0.9 by default, and if you feel like when you are doing tests, you feel like, oh, I don't want to modify the speed, but I feel like I want the line to be slightly thicker or print a little bit more. Basically, depositing more material at each and every location. When you don't change the printing speed, you can use this parameter. Because it is about the dispensing rate of how fast you squeeze the filament out, not how fast you move. How fast you move the gantry called printing speed. It's called printing speed. But how fast you extrude the material is called dispensing rate. That's controlled by extrusion multiplier. My software. Okay. So that's it, and it's kind of the same deal. Once we set this, it's the same. Left extruder, we also want everything to be 0 layer, and we can quickly go to addition. Now, actually, sorry, I made a mistake. So for the first layer, we want to use a skirt, but when we print the PLA, because it's already suspended in the air, we do not want to use the skirt anymore. So for this one, we check it, but for the one we made before, we should uncheck skirt. Please feel free to interrupt if you don't know what is skirt. And infill. So for the bottom layer, for when we print the substrate, only the top layer, the orientation of the print matters. For the bottom layer, it doesn't matter. Or because it's only a soft substrate, it's a constraint. We're not using any kind of orientational feature of the black layer, the bottom layer. So for the direction, we don't need to care. And you can set it to, just for your easy of life, you can set it to be also parallel. So it finish one layer, another layer, that's it, right? So we can all set it to be 90 as it is. But so one trick is you perhaps don't want to set it to be exactly the same as the top layer. Why? Because if you set it to be the same layer, the bottom is kind of constraining the movement. You'd better set it to be 90 degree compared to the top layer. So if our top layer set it to 90, here I would make it 0. So if we have more than 2 layers, this is the alternation. It'll repeat. So if I set 0, 0, 30, so let's say for example I can add one more 0, 0, 30, 30. What will happen if we have 6 layer? It'll print 0, 0, 30, 0, 0, 30. That's what I mean. If you just set 1 as, you can remove. If you just set 1 as 0, means it'll always use 0 for all the layers you have. Although here we only have 1 layer. But as a general rule, and you don't have support, and temperature here important. So right extruder, now we want it to be 0. We don't want right extruder to function. But now we want the left extruder to function. And it's set it to 230. That's pretty much right. So when we print soft material TPU, we usually require a higher temperature. So the official recommended temperature is between 230 to 235. Since 230 works okay for us, let's just make it 230 for now. And again, we don't want the heating platform to be heated. Now it's 0, perfect.
So right and left. The right is when I sit in the front, and then on the right, this side
right.
is right and left.
Right. And we set the left to be soft material, if you remember. Yeah. So we don't need anything. Oh yeah. So this is an important parameter I just missed to tell you guys. So adjust printing speed for layers below 15 seconds. That means if the layer is finished too fast, it will make that layer printed slower than what you set in the speed in the speed control function. don't want it because we want the print to be printed in the way we set it up. So we don't want this smart function. Uncheck it.
And what was the PLA?
Right. I will finish this. I will go back to the. So for the G code, we don't need to do anything. Unless if you have made offset for the PLA layer, then you want to do exactly the offset for the TPU layer. Otherwise, the two things won't fit, right? Won't be aligned in your actual print. That's it. So your printing speed can be set at the same. Usually, actually, this one I make it slower because the soft materials are relatively harder to print. So this one, to be safe, you can set it to be around 5,000 to 2,500 or 3,000, something around this, 3,000 ish, and nothing need to be set in advanced. Just remember to uncheck the retraction for here. And now we can select model, this being the bottom layer, right? Select the bottom layer. That's it. And let's go back to PLA because we mentioned we forgot two things. One is the layer, one is the cooling function, uncheck the retract. The other one is we do not want the skirt because this one is printing suspended in the air. If you do skirt, the skirt will also be suspended in the air. And now, if we want to simulate the print, you want to select both process. So this is the file, and this is the procedure. And you select both procedure, and then press prepare to print. And here, in order to simulate, I would choose both of them. And you can, usually I do continuous print layer by layer, sometimes use the other one. Ooh. Let's see what's happening. So now I switched to showing different color for two different tool head. So you can see that the bottom layer is printed with the green material. The bottom layer is printed with tool 1, and because now green represents tool 1, the blue represents tool 0, right? So you can see this view visualized. And then we can also try to switch to another mode called moving speed. And you can see the two layers are also representing different color because remember we set the bottom to be printed slower because I mentioned for the soft material it's important to make it slower. Yeah, so that looks pretty much right to me. Maybe I forgot something because sometimes I'm not so patient. You should have checked all the parameters carefully. But now it's time to generate G-code for our MakerBot. So now we actually want to prepare to print. We want to generate separate G-code. So we want to first select top PLA only and go to OK. And then now you can just like save to path to disk. I'll save it to the same place where here. So I call it bottom, and then exit, and then press again. Now I'll select only the bottom. Sorry, why I call it bottom? It should be called top. So now I will call this. See these little green lines? These are the skirt. Yes, I made it two layer skirt 4 centimeter away from the real material. And you can also see the printing path now is 90 degree compared to the top. That's what I want. This is to release this, to decrease the stress, to increase the bending. And for this one, again, I save it. This time I should remember to call it bottom TPU. Let's go to visit what we have saved. It's under So here inside the, sorry, it's here. Actually, you can see this one I made a wrong name. It should be top PLA, and the same. This one should be sorry. This one should be called top PLA. This one should be called top PLA. So, is there a way I can arrange it to date last date edit? Yes. So you can see it generated two file. Sorry, this doesn't really help. But basically, I can tell you because I know. So it generates basically top bottom TPU, and so these are the two files. Once we select bottom TPU generate, it generates two files. One file is in this 3xg format. This is the format MakerBot actually read in when you select the file from the microcard that has it on the machine. You only need to copy this file into. The reason it also generates a G code, I believe, is because they want us to read. We can open this, actually read the contents of it. I don't have a default software, but I know there are a lot of software that can handle the reading of G code. I believe you cannot use or maybe yes. Let's see. Oh, yeah, you can. You have to use some special software to read the G code file. But that's it.
It's binary code. It's not text.
It's actually text, but I'm not sure. Oh yeah, it's here. See? So yeah. So what I'm saying, or what I'm suggesting, so these are all headers. These things I think we can just simply copy. The most important stuff is all like here. X, Y, Z, and E, and F is the printing speed, and this is E is about the amount of material you extrude. So basically, define the coordination, define the amount of material you extrude from the previous coordination to the current coordination, and also at the beginning, you define the speed, the printing speed. So this is kind of the core. So ultimately in the software we want to make by our own, we kind of have to generate this.
The F25000 is the point that changes speed, is it?
Yes, but then if you do not rewrite, this will be kept as it is. All the others will be printed with the same speed. Remember we set it as 2500, right? And what's the reason it choose a few points to rewrite? I have no idea. No. It might be because in our print you see it's like going here, move to here, and going here, move to here. So you should have one coordinate being connected. Yeah. So, but yeah. So ultimately, my understanding, Kwang, you can after study that you may be able to tell me better. So the MakerBot file is like some sort of a encoding of this, but it's the same contents.
That's a weird.
And there are tools, if you Google, there are tools to convert G code to like a MakerBot readable.
So then it's a bit high level question. So you first wanted to show that those 5 of them.
Yes.
And now it makes sense. Now it makes sense because you want to making 5 different directions.
Angle, yeah. I want to show you guys how to do that.
Is it compute automatically, or you have to calculate the angles yourself?
In my card tool, in this card tool, I have to calculate automatically.
Okay. Good.
Yeah, but there are some tricks you can do the calculation, right?
How?
Because I mean, in a 3D software, we can already.
You can measure the angle.
Yeah, from starting point, what's the angle and stuff. Yeah. But I hope in our tool, those things we can have some smart way to define, or I don't know. We have to discuss like, so far I kind of switch between these two software, and you can tell there are a lot of limitations. Speed, for example, we can change speed as long as we select different units, but within one unit, we cannot really change the printing speed. But if we have our own tool, we can totally vary the speed as it's printing the same file.
So if they put F like 45 and then you see the you just check that. Did you check that actually the X that machine do then like slow and then fast and slow?
I'm pretty sure. Yeah, I'm pretty sure it can.
I haven't tested yet. Okay.
No, but you can imagine in the G code if we say you're still here, right? So if we move here with 5 2000 and then we add another one, like I don't know 5 2000, 5 here 5 1000, it will for sure slow down and speed up.
So is there anything else you want to show in the software
side? That's it. So for now, I think there are. I mean, I kind of touch different parameters. There are reasons why those parameters could be useful, like offset and all the others. But I think for now, you can kind of just choose some. I'll send you the video, so you guys can decide together which samples you want to print and test. I suggest you to practice kind of the whole flow and make sure you can print something out. Start with the simplest one, but maybe do a slightly change. Maybe do like an angle print instead of parallel. And starting from there, maybe I think it makes sense to replicate some of the interesting example to just give you some inspiration. And from there on, we can start to think what will be the more interesting shapes to print or design to do, or like speed control or whatever, this kind of thing. Yeah, but the basic workflow is like this. And from here on, right? Just copy the file into the chip.
Can you try? I mean, I'm curious how it looks like.
Oh.
Yeah.
This one is just gonna be a simple stripe, right?
I don't know. I like do it and then I wanna put it in the hot water and complete the process.
Yeah, can you grab the microchip from me?
Oh, sorry. You mind if I just push it and then take it out?
That's what you should do.
Why is it on off the machine or not?
No.
No? Okay. Here.
Okay. I will re-export the top because I messed up. Yeah. So now I can stop this thing, right? I will put it temporarily in box.
And then you can drag and drop on the Slack. I uploaded all the files in the Slack channel.
This will be big. Is this thing that big? Can be. Oh, you send the link, not the entire file.
Entire file. I have uploaded in the Slack.
I think it might be too big. I'll send you a link.
Yep.
By the way, I am trying to. By the way, so I'm trying to practice the idea of coordinating the same way of naming files for the group. So I suggest we use year 2017, 17, 17, 07, 010. So basically year, month, date, and then underbar, and then the title of your stuff. And then the title of stuff all lower letter. And if you want to say tutorial 1 and you want to explain even more, you can do tutorial 1 and the bar again, thermorph strat. So we can use this for everything. So folder name, like Word documents and video.
The space is always kind of problem.
Oh, let's all use underbar then, like this. You think this would work?
I mean, then this is kind of it's underbar and underbar, but this is the actual one unit and explanation. So dash. These days people use dash for these things. But some of the software not accept of dash. Underbar is good. Underbar is always works.
Okay.
So everyone.
No, I think it's okay.
It's good. Okay.
Yeah, we don't need to divide further explanations or yeah.
Underbars are good.
Underbars are good, right?
Safe, yeah.
This is good for programs.
For program.
Yeah. Also, I like it because a lot of folders are arranged by the first name. So if we have a year, month like this, we always categorize everything with the date first.
So, but in the visual perspective, dash is better. So these days, many people move onto the dash and the underbar for space. But then some code is not accept the dash, and then they forced to update in the underbar some as some kind of fixing. What is it? So I mean, it's a kind of history.
Okay, underbar.
Okay, underbar good.